Hello everyone, I am Patel Prince Virendra Kumar. My ID is 24CH072. I am from CSE CSPAT Charukha. Today I am presenting on the topic Digital Logic in GPU. This presentation will explore how digital electronic concepts like GAT and flip-flop are working of modern table of quantum. Here a quick look at the structure of today's presentation. We will begin with an introduction to GPUs, their importance, architecture, and then move into the core. How digital logic operates inside a GPU. We will finish with a real GPU example and wrap up with conclusion. Introduction to GPU. GPU graphic processing units were originally designed to render image and video, but over time they will become gaming, AI, and scientific computing thanks to their parallel processing capability. Popular GPU brands include NVIDIA and AMD. Why GPU are important? GPU handle massive amount of data and they make a key visualize computing and real-time rendering, machine learning, and simulation. Their ability to process in parallel is what sets them apart from CPU. GPU architecture overview. This diagram shows the internal architecture of GPU. It includes components like GPC, CUDA, Tensor, RAP, RT. All these units work together to manage data flow, platform calculation, and enable to parallelization. Uh, we will see first GPU and small part of GPC. Then after we can small part of RAP in GPC and with also RT. Then after we see CUDA and Tensor in RAP. This is the all structure of GPU. What is digital logic? Digital logic is foundation of all modern electrical systems. It works using binary 0 and 1 and user basic gate like AND, OR, NOR and universal gate like NAND and NOR to perform operation. Everything inside a GPU from storage to computation is based on their logic. Digital logic in GPU uh, di- manage how data flow and what operations are performed. XOR gate help into arithmetic operation, while NAND and NOR gate are used in building memory components like flip-flop. All tasks from decision making to execution rely on this digital logic. Flip-flop and storage. Flip-flop are the one byte memory element. They store data temporarily and they essential in the design of register and memory control unit. Different type of flip-flop are available in CUDA like D, JK, T flip-flop, etc. to hold value during instruction cycle. Register in GPU. Register are the created using flip-flop in the GPU, especially in CUDA code. Each thread use multiple registers to store immediately data. They allow fast access and help avoiding delay caused by accessing slower memory. ALU in GPU. ALU, Arithmetic Logic Unit, perform mathematical and logical operation. In the GPU, each CUDA code has in one simple ALU, which uses gate like XOR for additional and and or for logic comparison. These ALUs are small but numerous. Control logic in GPU. Control logic manage how operations flow into GPU and it built using both combinational and sequential circuits. It ensures that each thread on instruction is executed in the right order, preventing data hazard or miscommunication between components. Parallel processing logic. GPU are parallel processing technique to handle many tasks at once. In CUDA, threads are grounded into wraps. Logic gate help decide which threads are active and when this logic enable real-time rendering and high-speed computation. Timing and flow. The GPU's internal operation are using clock signal, flip-flop and buffers rely on this clock pulse and transition between state. Timing logic ensures that operation happen in sync to the data is transferred correctly across pipeline stage. Boolean algebra in GPU. Boolean algebra is used to simply logic circuit inside GPU by minimize the number of gates. The engineer can make CUDA cores more efficient. This helps reduce power usage and increase speed without sacrifice performance. Now, logic in graphic tasks. Graphic tasks like shading, blending, and depth buffering after done using logic operation. For example, XOR gates handle light reflection calculation, while AND gate help in texture mapping. Every pixel we see in result of such a logic. Power of management logic. Modern GPU includes smart power saving technique. Logic circuit can turn off idle cores using clock gating, which use and not gate. This reduce heat output and save battery in mobile device and also in laptop. Real GPU example. Here a real world example like NVIDIA CUDA cores and AMD compute unit, both really on the principle of digital logic. Every part, whether it's ALU, register, FSMS, and also made of logic gate and flip-flop that we study in digital electronics. Conclusion. In conclusion, CPUs are the high-speed device built internally from digital logic components. Logic gate, flip-flop, FSMS, they all work together and deliver incredible parallel performance. What is the learn in the class directly applied this the powerful processors. That's all. Thank you for listening.